First is the relative minimum and relative maximum. So what's the definition of relative minimum? Relative minimum means that the height of all points nearby. Yeah? So the relative minimum means the low points. The low points nearby, yeah? And the relative maximum means the high points nearby. And then we introduce the critical points. So what's the definition of critical points? Critical points means actually is the derivative equal to 0 or the derivative does not exist. Yes? Does not exist. And so this is the critical points. Critical points equal to two points. Okay, the first thing is the derivative equal to 0 or derivative does not exist. And then we introduce that the stationary point. So stationary point is what? The stationary point. The stationary point actually is the derivative equal to 0. Yeah, equal to 0. So this is the critical point. And now let's see the actually we have a conclusion means that the function, okay, the relative maximum or minimum actually is the relative extreme, okay, extreme actually occurs at the relative the critical point. The critical point. So here means actually, so we have this conclusion, okay, so here, So here, suppose that f is a function defined on an open interval containing the point x0. So if f have a relative extrema at x equal to x0, that means that x equal to x0 is a critical point of f. So here means what? Here means actually the derivative equal to 0 or f is not definable at x0, okay? At x0. So here means that the relative extrema is the critical point. So here we can plot a graph to show the relationship between critical points and the stationary points and the relative extrema. Okay. So first we know that the stationary point actually is the critical point. Yeah. And the relative extrema is the critical points. Yeah. So here actually we have this relationship. The relationship is like this. The biggest is the critical point. Here is the critical point, and the stationary point actually is a part of the critical point. So here is the stationary point. And we also know that the relative extrema actually is also critical points. So here we have another part. This part actually we can see it as relative extrema. So this here, this figure says that the stationary point is the critical point. And the extrema, relative extrema is also critical point. And sometimes stationary point is relative extrema. Okay. Sometimes stationary point is relative extrema. Okay. So this is the relationship between these 3 points. Okay. Now, so next we introduce how to find the relative extrema. Okay, how to find the relative extrema. So first, now let's see some functions. So here, so I think that the blackboard is so small, so I needed to blackboard. Okay. So come back. Yesterday we introduced how to find the critical points. Find the critical points actually is you find the derivative equal to 0 or the derivative does not exist. Now for this function, okay, y equal to x squared. For this function, we know the graph. The graph of the function is like this. Here is y. So here is y equal to x squared. Y equal to x squared. So here, now we can see the point 0. Okay, the point 0. Actually, here in this point, we can see for this function f(x) equal to x squared. So f prime equal to what? F prime equal to 2x. Yeah. And at the point 0, so we let x0 equal to 0. we can see that f prime x0 actually equal to 2 times 0, yeah? So it's 0, it's 0. So here means that x0 is the stationary point of the function, yeah? So x0 is the stationary point. Of course, it's the stationary point, of course, it's the critical point, yeah?
Yeah.
So it's also critical point. It's also the critical point. So the x0 actually from the graph, we can see that x0, 0 actually is the relative minimum, yeah? Relative minimum because it's the low point nearby, yeah? So here is the relative, relative minimum. So this is the first example, okay? Now for the second, now let's see this function y equal to minus the absolute value of x. For this function, okay? For this function, we know y the slope. We know the graph of y equal to absolute value of x. Actually, is a v-shaped, yeah. So minus x absolute value of x actually is a v-shaped like this, yeah, like this. So here actually the graph like this. Yeah. So here is y equal to minus absolute value of x. So for this function, okay, we also see the point 0. x0 equal to 0 for this point, okay? So for this point, it's easy to see that the point is a critical point. Of course, you can see at this point the left limit actually the left slope actually is minus is 1, yeah? And the right the right slope actually is minus 1, so they are not the same. Yes, here means that at this point the derivative does not exist, yeah? So this point actually is the critical point, yeah? It's critical point. So x0 is the critical point. It's a critical point. Critical point, but not a stationary point, yeah? Not a stationary point. So not a stationary point. And now this point actually is a relative maximum, yeah? Because it's easy to see, yeah, it's a relative maximum. Relative maximum. So here this is for this example, okay, for this example. And now so from these two, okay, from these two example we can see it's easy to see, okay, at this point, at the first point, at this point, okay, this point, the left we can see, okay, on the left of 0, the derivative means when x less than x0, when x less than x0. When x less than x0 means x0 is 0. When x less than 0, we can see f prime x equal to 2x. Here is greater than 0 or less than 0. When x less than 0, 2x of course less than 0, yeah? Less than 0. And when x greater than 0, when x greater than x0, so here means f prime x equal to 2x. When x greater than 0, here 2x of course greater than 0, yeah? So here means that on the left of 0, the derivative is negative. On the right of 0, the derivative is greater than 0, positive. So here means that the derivative, okay, the derivative have opposite signs, okay. So here means that the derivative derivatives have opposite sign. On the two sides of x0. On the two sides of x0. So here for this example, we have this factor, okay? For this one we can see, do we have the same convolution? For this, okay? For here we can see when x less than x0 is 0. When x less than x0, so the derivative of x equal to what? Actually, when x less than 0, fx equal to minus absolute value of x. When x less than 0, absolute value of x actually is what? Is minus x, yeah? Minus x, so it is equal to x, yeah? So where x less than 0, fx equal to x. When x greater than 0, okay? When x greater than 0, fx equal to minus absolute value of x equal to what? Equal to minus x, yeah? So here we can see when x less than 0, fx equal to x. So f prime x equal to what? So this derivative is 1, yeah? Is 1. So when x less than 0, the derivative is positive. And when x greater than 0, f prime x equal to what? F prime is minus 1, yeah? Minus 1, so it's negative. So the left is positive, the right is negative. So of course, the derivative has opposite signs on the two sides of x0. So here this is the conclusion for these two, okay? For these two examples. Now let's see the second example, the third example. So y equal to x cubed. Okay, y equal to x cubed. For this function, okay, here is x, here is y, here is x, here is y. Here is x, here is y. So here now let's see. The graph actually is like this. Here is y equal to x cubed. Now we also see the point x0. So x0 equal to 0. So fx equal to what? Equal to x cubed. So f prime x equal to what? Equal to 3x squared. So here now we can see f prime x0 equal to 3 times x0 square. X0 equal to 0. So here is 0. Yeah. So here is what? Here means x0 is a stationary point. Yeah. X0 is a stationary point. Of course, it's a stationary point. Of course, it's a critical point. Yeah. So it's a critical point. But this point is a relative maximum or minimum. Of course, no. Yeah. This point, okay. This point is not a relative maximum or relative minimum. Yeah. So here, this point, okay, this point is not a extremer, not a relative extremer. So this point, okay, this point is a stationary point, is a critical point, but not a relative extremer, okay, not a relative extremer. So now we also see. For this function, okay, and when x, now we can see the sign of the derivative. When x less than x0, when x less than x0, we can see f prime x equal to 3x squared is positive or negative. When x less than 0, 3x squared positive, yeah. So here is positive. So, and when x less than or greater than x0, so we can see f prime x equal to 3x squared. When x greater than 0, 3x squared is also greater than 0. Yeah, so positive. So here means at this point, the left derivative is positive, the right derivative is also positive. Okay. So here for this function, for this example, okay, the derivative, have the same sign, okay, have the same sign on the two sides, of x0, okay, of x0. So here, so actually, this three examples tell us when the critical point will be a extremer or a relative extremer, when some. So here means that a critical point, okay, a critical point sometimes it will be a relative extremer, sometimes it will not. So these two examples tell us that if the derivative, okay, have opposite sign on the two sides of x0, then the critical point will be the relative extremer. If the derivative have the same sign, okay, on the two sides of x0 here, so the critical point will not be a relative extremer, okay, will not be a relative extremer. So this example tell us that when the derivative have the opposite sign, okay, have opposite signs on the two sides of x0, then x0, the critical point of x0 will be the relative extremer. And when the derivative have the same sign on the two sides of x0, okay, the x0 will be not a relative extremer, okay. So here for this one, okay, also we can see the clearly if the left, okay, if on the left of x0 the derivative is negative and the right of x0 is positive, then this time is a relative minimum, okay, minimum. So here, for example, here is x0. Here is x0 on the left, f prime is less than 0, and on the right, here is x0, okay. On the right, greater than 0. So in this case, okay, in this case, x0 is in this case x0 is a relative what? Minimum. Why? Actually, it's easy to see. Okay, f prime less or f prime less than 0 means it's decreasing. Then it's decreasing. F prime greater than 0 means it's increasing. So the left is decreasing, and right is increasing. So the point actually is a relative minimum. Yeah, a relative minimum. Yeah.
Yeah.
So the second, okay, when x0, here is x0. So if the left is greater than 0 and the left is less than 0. In this case, okay, in this case we can see the left is greater than 0 means increasing. The right is less than 0 means decreasing. Yeah. So the left increasing, the right decreasing. Yeah, decreasing. So here is x0. So x0 is what? x0 here is relative maximum. Yeah. So the relative maximum. Yeah. Relative maximum. So here this is this convolution. Okay, this convolution means that in mathematics this convolution means that the first derivative test. Okay. So here now let's see the PPT. Okay. Now let's see the PPT here. Here are the first derivative test. Okay. The first derivative test. Suppose that f is continuous at a critical point. At a critical point, if f prime greater than 0, on an open interval extending left from x0, and f prime less than 0 on an open interval extending right from x0, then f have a relative maximum. Okay, maximum. And if f prime less than 0 on an open interval extending left from x0, and f prime greater than 0 on an open interval extending right of x0, then f have a relative minimum. Okay. So the third C, if f prime have the same sign on an open interval extending left from x0 as it does on an open interval extending right from x0, then f does not have a relative external at x0. Okay? Right, at x0. So here, so the C actually is the number, the third. It's the third, okay, it's the third example. So here, this is the conclusion, okay? So this is the conclusion. So actually, title is not convenient, okay? From here to here. So I want to change the class to that's class, okay? So I want to change the class. So okay, so here, so here this is the first, okay, so I think that you just to remember here, this is the A, this is B. If the derivative left is negative, right is positive, so here means first here means increasing, so here is relative minimum. So here the second the derivative left is positive, right is negative. So here increasing, so relative maximum. So here number C here it means f prime x0. Oh no, I made a mistake here. When f prime x greater than 0 on the left greater than 0, on the right is also greater than 0. Okay. So here means it is increasing. Yeah. So here this case, okay, this case means the function on the left is increasing, on the right is also increasing, yeah, also increasing. So this point is not a relative extrema, okay. So here is not a relative extrema. And if the left is less than 0, the right is also less than 0. Okay, less than 0. So less than 0, left less than 0 means it's decreasing. Yeah, here is x0, and the right is also less than 0 means it's also decreasing. So here this point is also not a relative extrema. Okay, so here this part actually is the first derivative test. So now we will use this test. We will use this test to find the relative extrema. Okay. So here now we give an example. Okay. We give an example. Now here, find the relative extrema of fx equal to 3 times x to the power 5 by 3 minus 15x to the power 2 by 3. Okay, 2 by 3. So here, okay, for this example, so first, okay, you need to find the derivative, and find the critical points. Okay, we know that the relative extrema is the critical points. Yeah. So the first step, we need to find the critical points. Okay, the critical points. So here, fx equal to 3x to the power 5 by 3 minus 15x to the power 2 by 3. Okay, 2 by 3. So f prime equal to what? So f prime equal to 3 times 5 by 3x 5 by 3 minus 1. Yeah? And minus 15 times 2 by 3 x to the 2 by 3 minus 1. Yeah? So here is 5. Here is 5. Here is x to the power 2 by 3. Yeah? Minus here 15 times 2 by 3, so it's 10. It's 10 times x 2 by 3 minus 1. So here is minus 1 by 3. Yeah? So here this is the derivative. So the derivative, we can see that here we can take out here x 2 by 3. Okay, x 2 by 3 we can rewrite it in this form. It's equal to x here is x1 minus 1 by 3. Okay, 1 minus 1 by 3 So here x1 minus 1 by 3, actually here we can see x times x minus 1 by 3. Here 5 times x to the power minus 1 by 3. And minus 10 x to minus 1 by 3. So we take out 5 and x to the power minus 1 by 3. So it is equal to 5x minus 1 by 3. So here is x minus 2, yeah? Minus 2. So here we can divide it in, here is 5, here is x minus 2, here is x minus 1 by 3, actually is 1 by x, 1 by 3, yeah? 1 by 3 actually is the cube root, yeah? Here is the cube root, so here is the cube root of x, the cube root of x. So we let it equal to 0, okay? We let it equal to 0, we let it equal to 0. So we let it equal to 0, we can see that x, actually, here we can find x equal to 2, yeah? X equal to 2. So x equal to 2 is the stationary point, yeah? X equal to 2 is the stationary point. So here we use a sign here x1, okay? x1 equal to 2. x1 equal to 2 is the stationary point. And now we can see that f prime does not define on 0, yeah? On 0. So here means that f prime, okay? F prime x is undefined. Undefined on the point x equal to 0, okay? x2 equal to 0. So here actually x2 equal to 0 is a critical point, yeah? So here x2 equal to 0, here is a critical point. So to here we find the critical point. We find the critical point of this function, yeah. So here means that the relative excitation must at here or at here, yeah. So now we can see here the first, here is 0, here is 0, here is 2, yeah. Here 0, here is 2. So we can see 0, 2 decompose the whole x coordinate to 3 parts. 3 parts. The first part is minus infinity to 0. The second part is 0 to 2. The third part is 2 to plus infinity. Yeah. So here now we can see. So now we can see the interval. The intervals and the f prime and the convolution Now let's see the intervals. The intervals first is minus infinity to 0. In this interval, okay, f prime is positive or negative. So now we can see when for this one, okay, with this one, it is the same, okay. We choose a special function, or we will choose a special value in this interval. For example, minus 1. So minus 1, and now we can see f prime minus 1 equal to what? F prime, so here 5 times minus 1 minus 2, yeah? And the cube root of minus 1. So here is 5 times, here is minus 3, here is minus 1, yeah? So of course it's positive, yeah? So it's positive. So here means here is positive, so here is increasing, decreasing. So here is increasing, yeah? Increasing. So here this is the first interval. The second interval from 0 to 2 in this interval, okay? in this interval, now we can see first the same, okay? We choose a special value on this interval. For example, 1. 1 belongs to this interval, yeah? So now we compute f prime 1 equal to what? F prime 1 equal to 5 times 1 minus 2 divided by the cube root of 1. So it is equal to 5 times 1 minus 2 is minus 1. The cube root of 1 is 1. Yeah. So the result actually is minus 5. So it's less than 0. Yeah. So here is decreasing. Yeah. So here is decreasing. So here we can see on the 0, okay? On the left of 0 is on the left here is 0. On the left of 0 is increasing, and on the right of 0 is decreasing. Yeah, decreasing. So the 0 is a relative maximum. Yeah. So from here we can conclusion that the point 0 is a relative maximum of the function f. Yeah. Now, so we have the first conclusion. Okay, 0 is a relative maximum of fx. Now we can see in this interval from 2 to plus infinity. From 2 to plus infinity. So here is 2, here is plus infinity. In this interval, okay, in this interval the same, okay. We choose a value belongs to in this interval. For example, we choose 3. We choose 3, so f prime 3 equal to what? Equal to 5 times 3 minus 2, the cube root of 3, yeah? So here is 5 times 1 divided by the cube root of 3. So the cube root of 3 is positive or negative? Positive. 1 by positive times 5, so it's positive, yeah? So it's positive, so greater than 0, so positive. So here is positive. So here means it's increasing, yeah? So from here is 2, here is 2. So on the left of 2 is decreasing, on the right of 2 is increasing. So 2 is a relative minimum, yeah? So here we have the second conclusion. 2 is a relative, so it's a relative minimum of fx. So here this is the answer. Okay, this is the answer. So now we can see that the first step, okay, the first step is you need to find the critical points. All the critical points, we can see that we find 2 critical points. And the second step is you need to see on the critical points, on the left of the critical points, the derivative is positive or negative. On the right of critical points, the derivative is positive or negative. And then we use the first derivative test to see is to see is a relative maximum or is a relative minimum. Okay. So can you understand? So now we do an exercise. So use the first derivative test to find the relative extrema, okay? To find the relative extrema. So the first function is fx equal to 3x squared minus 6x plus 1. The second function is gx equal to x cubed minus 3x plus 3, okay, plus 3. So here, so now do these two exercises, okay, do this exercise. Use the first derivative test to find the relative extrema. So the first is fx, this function, the second is this function, okay?
Don't worry, you can do it. Now guys, I'm not about this to
So I have right, okay, I have agreed. The first one, okay. So the first one is the same, okay. First you need to find the critical points, yeah, the critical points. So here number A, you need to find the derivative. So the derivative equal to, here derivative is 3 times 2 times x, yeah. So it's 6x minus 6x, 6, yeah. And plus 0, yeah. So here is equal to 6x minus 1. That is equal to 0. That is equal to 0. So here, from here we can see that the x equal to 1, yeah? X equal to 1 is the stationary point, yeah? Is the stationary point. So now we need to see on the left of 1 and on the right of 1, okay? So here is x, so here is 1, here is 1, so we need to see two intervals. The first is minus infinity to 1, the second is 1 to plus infinity. So here is interval, here is f prime, here is the conclusion. Here is the conclusion. So here the first interval is minus infinity to 1. So when x is less than 1, so f prime is positive or negative? Negative, yeah. So negative, so here is decreasing, yeah. So here is decreasing. And the second interval, so here is 1 to plus infinity. 1 to plus infinity when x greater than 1. Here is positive or negative?
Positive.
Positive. So here is positive. Positive. So here is increasing. Yeah. So it's easy to see on the left of 1. On the left of 1 is decreasing. Decreasing. On the right of 1 is increasing. So this one is what? Is minimum, yeah. So x equal to 1 is the relative minimum of fx, yeah, of fx. So here this is the answer of the first one. So it's easy, yeah, it's easy. So can you get the right answer?
Yes.
So now for the second one, okay? For the second one, so here, first we find the derivative, okay? Find the derivative. So B here, gx. So g prime equal to what? G prime equal to 3x squared, yeah, minus 3, yeah, minus 3. Yeah, so here equal to what? Equal to 3x squared minus 1, yeah. So here that is equal to 0. That is equal to 0. So we can see x equal to what? Minus 1 or plus 1, yeah. So here x equal to plus 1 or minus 1 is the stationary point, yeah. It's the stationary points of gx. So here we need to see what? We need to see plus 1 and minus 1. Here is minus 1. Here is plus 1. So here we can see we have 3 parts. The first part is minus infinity to minus 1. The second is minus 1 to 1. The third is 1 to plus infinity. Yeah. So here now we need to see this part. Okay, this part, the intervals, and here is the prime. The derivative here is the conclusion. Here the interval, the first interval is minus infinity to minus 1. In this interval, okay, in this interval, so g prime is greater than 0 or less than 0. When x in this interval, yes, negative. For example, you can choose a number here, minus 2. So minus 2 squared minus 1. Of course, it's positive, yeah? So it's positive. So in this is increasing, yeah? Is increasing. Now for the second here is minus 1 to plus 1, yeah? So here is minus 1 to plus 1. So boys, so stand up and answer me. Here, let's stand up. Yeah? Stand up. Yeah. So here, when x in this interval, g prime equal to 3 times x squared minus 1. This, when x in this interval here, this one is positive or negative. X squared minus 1 is positive or negative? What? Positive or negative? Negative, yeah. So here is negative. So here is negative, so here is increasing or decreasing? So here is decreasing, yeah. So sit down, okay? So decreasing. And now let's see the third interval. Here is 1 to plus infinity. Okay, 1 to plus infinity. In this interval, so in this interval here is positive or negative? Of course, positive, yeah. So here is positive, so here is increasing, yeah. It's increasing. So now we can plot the graph, okay. Here is minus 1, here is 1. So on the left of minus 1, here is increasing, and on the right of minus 1 here is decreasing. Yeah, and on the right of 1 here is increasing, so it's like this, okay? So we can see that minus 1 is the relative maximum, yeah? So x equal to minus 1 is the relative maximum. Relative maximum of gx. And x equal to 1, okay? And x equal to 1 is relative minimum, yeah? Minimum of gx. So now from these three examples, we can see how to find the relative axioma. Use the first derivative test. So actually, the first you need to find the critical points, and then on the left of the critical points, you see the sign of the derivative. On the right of the critical points, you see the sign, yeah, of f prime. So now you can use. So from here you can see the conclusion. So here is the first derivative test, okay? Of course, we have first, we have the second, okay? So next we introduce the second derivative test. So here now we see we introduce the second, okay? The second derivative test. The second derivative test here first we see an example. Here, for example, for this example, here is y equal to, here is x, here is y, here y equal to sin x, okay? Here is 2 pi. So this function is y equal to sin x. For this function in the interval 0 to 2 pi, okay, in this interval. Now actually it's easy to see here. X2 here is 1/2 pi, and here is 3 pi by 2. Okay, 3 pi by 2. So it's easy to see 1/2 pi actually is a relative maximum, yeah? And 3 pi by 2 is a relative minimum, yeah? So now we can see the first derivative at this point and the second derivative at this point. So here now fx equal to sin x. Fx equal to sin x. So f prime x equal to what? Equal to cosine x. Equal to cosine x. So we can see f prime 1/2 pi. F prime 1/2 pi equal to what? Equal to cosine 1/2 pi. Yeah. Cosine 1/2 pi is what? Cosine 1/2 pi.
0.
0, yeah, 0. And now we see the second here. 1/2 of f prime of 3 pi by 2 is cosine 3 pi by 2 is what? It's also 0, yeah? It's also 0. So here means what? Here means 1/2 pi and 3 pi by 2. These 2 points are the stationary points of the function fx. Yeah? Now, okay, so we can see in this part, okay, in this part, we can see is concave up or concave down. In this part, okay, in this part, from 0 to pi, okay, we follow the dashed line. The dashed line actually is like this. So here we can see the curve, okay, the graph is less below the dashed line, yeah. So this part, on this part is concave up or concave down. concave down, yeah? So concave down means what? Means F prime is positive or negative?
Negative.
Negative, yeah? So here F prime is negative. It's negative. So here means what? So here means F prime 1/2 pi, okay? So here means that F prime 1/2 pi is negative. So now actually here we just this conclusion just see from the graph. Actually we can compute it, okay? We can compute it. So F prime equal to cosine x. F prime equal to what?
Negative sin.
Is negative sin x, yeah? Negative sin x. So F prime 1/2 pi equal to what? Equal to minus sin 1/2 pi, yeah? Minus sin 1/2 pi is what?
-1.
Is minus 1, yeah? So of course it's less than 0, yeah? Less than 0. And now we can see in this part, okay? In this part, from pi to 2 pi, in this part, we can plot the tangent line. We can plot the tangent line. Actually, it's like this. It's like this. So it's easy to see that. It's easy to see that the graph lies above the tangent line. So this part actually is concave up or concave down.
Up.
Concave up, yeah?
Yeah.
So concave up means that F prime is greater than 0 or less than 0.
Greater than 0.
Greater than 0, yeah? So F prime is greater than 0 at this point. So here means that F prime 3 pi by 2 in this is greater than 0. Okay, it's greater than 0. Greater than 0. So actually here, this conclusion we see it from the graph. Actually we can compute it, okay? Actually we can compute it. F prime 3 pi by 2 actually equal to minus sin 3 pi by 2, yeah? So sin 3 pi by 2 equal to what? Sin 3 pi by 2 actually is minus 1. Minus 1, so here is actually 1, okay? So it's greater than 0. So here now we can see at this point, 2 F prime 1/2 pi equal to 0. F prime equal to 0. F prime less than 0. So this point is what? Is a relative maximum. Okay. So here this point is relative. So 1/2 pi is a relative maximum. Okay. Maximum. Here means F prime equal to 0. F prime less than 0 is a relative maximum. And now for this point, F prime equal to 0. F prime greater than 0. Okay, so here 3 pi by 2. This here is what? Is a relative minimum. Okay, so here this part actually is the second derivative test. If a function at the point, the first derivative equal to 0, and the second derivative at this point is less than 0, then this point is a relative maximum. And the first derivative, if first derivative equal to 0, second derivative greater than 0, so it's a relative minimum. Okay. So here, okay, now actually we can prove it. Okay, we can prove it. So now we prove it. Okay, we give an easy proof for this conclusion. Okay, for this conclusion. So here, so for this one, okay, if a function, the conclusion is here is some x0, okay, some x0, f prime, this point is equal to 0, f prime, okay, this point, okay, this f prime here is less than 0. So we want to prove that x0 is a relative maximum, okay, maximum. So we want to this is the condition, this is the condition, this is the conclusion. We want to prove this conclusion, okay? So here, now, actually it's easy, okay? It's easy. For example, here, we know the f prime prime x0. We use the definition. Here actually equal to what? Equal to f prime. So here actually equal to limit x approaches x0 f prime x minus f prime x0 divided x minus x0. Yeah? This is the definition. This is the definition of f prime prime x0. Yeah? So now we can see f prime x0 equal to 0. Here means this equal to 0. This equal to 0. So here equal to what? So here equal to limit x approaches x0. Here f prime x divided, here is minus 0. So here is this one, okay? Here is x minus x0. So we can see this one, okay? This limit less than 0. Less than 0. Okay, less than 0. Less than 0. So here we can see if x minus x0, yes. So here we can see when x less than x0, when x less than x0, so here means this denominator is positive or negative. Here is negative, yeah? Negative, so a number divided by negative should be negative. So this number is positive or negative? Positive, yeah? So here we can see we have f prime x positive, yeah? And when x greater than x0, when x greater than x0, so the denominator here is positive or negative?
Positive.
Positive. So here we need to see this one less than 0. So this is positive. So this should be
Negative.
negative, yeah? So here we can see f prime x should be negative. So we can see when x less than x0, here is x0. So when x less than x0, the f prime greater than 0. So here is increasing, yeah? And when x greater than x0, so here f prime less than 0. So this one is decreasing, yeah? So of course this point is a relative maximum, yeah? So for this one, actually it's the same, okay? It's the same. Now, of course, okay, we have a conclusion, we have a question. So what about if f prime x0 equal to 0, if f prime x0 equal to 0, and f prime is also to 0, so x0 is what? Is what? So we have this question, okay? If the first order derivative equal to 0, the second derivative is also equal to 0, okay? So x0 is what? Is relative maximum, relative minimum, or what? So actually here we give an example. We give an example for this. Now for this case, okay, the first order derivative equal to 0, second order derivative is also equal to 0, okay. Now we need to see x0 is what? X0 is what? So we give an example. The first example is fx equal to x to the fourth power, okay, x to the fourth power. So actually the graph is actually like this. The graph actually is like this. Is like this, okay? So here we also we see what? We see x0 equal to 0. X0 equal to 0. So we can see f prime x equal to what? Equal to 4x cubed. F prime x equal to what? Equal to 5x squared, yeah? Yeah? So it's easy to see f prime 0 equal to what? 0, yeah? f prime equal to what? Is also 0, yeah?
Yeah.
So in this case, we can see 0 actually is the relative minimum, yeah? So in this example, 0 is a relative minimum. This is the first example, okay? Now we see the second example, fx equal to minus x to the fourth power. For this function, okay, we also see x0 equal to 0 at this point, okay? At this point. So here the graph, okay? The graph actually is like this, okay? Is like this.
Double zero.
So here we can see f prime equal to minus 4x cubed. F prime x equal to minus 5x squared. Yeah? So we easy to see f prime 0 equal to what? Minus 4 times 0 cubed. Yeah? So 0. And f prime 0 equal to minus 12. 0 squared. Yeah? So it's also 0. So f prime equal to 0, f prime equal to 0, and this point is a relative maximum. Yeah? So it's a relative maximum. So this is the second example. Now we give a third example. The third example, for this example, fx equal to x cubed. Also at the point x0 equal to 0. So we can see this graph, okay? This graph actually is like what? This graph actually is like this. It's like this, okay? Here is y equal to x cubed. Y equal to x cubed. So we can compute it. F prime equal to what? F prime equal to 3x squared. F prime equal to what? Equal to 6x. Yeah? So it's easy to see f prime x0, f prime x0 actually is 3 0 squared. So 0. Yeah? And f prime x0 is equal to what? 6 times 0. So it's also 0. Yeah?
Yes.
So f prime 0, f prime 0, and 0 actually is not a relative minimum and not a relative maximum. Okay? So x0 or 0 actually is neither a relative maximum
Either relative minimum.
nor a relative minimum. Okay? So here tell us that. So from these three examples tell us that if f prime x0 equal to 0, f prime is also equal to 0. Here x0 we do not have any conclusion. Okay? We do not have any conclusion. Okay? So from here we have the second derivative test. Now we see the PPT. Okay? So
এমনি তো ভালো আছে
now we see the PPT. Okay? The second derivative test. Here. So suppose that f is twice sectionable at the point x0, if f prime equal to 0 and f prime greater than 0, then f have a relative minimum at x0. Okay. The second B, okay, if f prime equal to 0, f prime less than 0, okay? Then f has a relative maximum at x0. So the third, if f prime equal to 0, f prime equal to 0, okay? Then the test is inconclusive, okay? That is, f may have a relative maximum, a relative minimum, or neither at x0, okay? So here now, I ask you that. You need to remember these two, okay? F prime equal to 0, f prime greater than 0, relative minimum, okay? F prime equal to 0, f prime greater than 0. So in this case, it's a relative what? Minimum. Okay, minimum. If f prime equal to 0, f prime less than 0, so this case is a relative maximum. Okay, so here I think that you need to do this. Okay, this means that the second derivative test. The second derivative test. Okay. So here. I'm sorry you needed to prepare this. So here, now, okay.
You don't have.
Now let's see this example. Find the relative integral of fx equal to 3x to the 4 5 r minus 5 times x cubed. Okay, x cubed. So actually, for here is a polynomial. So the polynomial actually is the continuous. Yeah. So also is the derivative is definable everywhere. Okay. So here now we can see.
Is this your real hair?
So first we find the derivative f prime.
How can I do
F prime equal to what? Equal to 3 times 5
You
x
can make mine.
5 minus 1. Yeah. Minus 5 times 3x 3 minus 1. Yeah. So it is equal to what? So it is equal to 15x to the 4th power minus 15x squared. Yeah. So the result actually is 15x squared times x squared minus 1. Yeah. Minus 1. So that is equal to 0. That is equal to 0. That is equal to 0. So we can see x equal to what? X equal to 0 or x squared equal to 1. Yeah. X squared equal to 1 means x equal to plus 1 or minus 1. Yeah. So here x or plus 1 or minus 1. Plus 1 or minus 1. So here this is the first derivative. So we need to see what? We need to see this point is minimum or maximum. So we need to see what? The second derivative. Okay? The second derivative. So the second derivative f prime x equal to what? Equal to this prime. Yeah? This prime is what? Is 15 times 4x times x to the power 4 minus 1. And minus here 15 times 2x 2 minus 1. Yeah? 2 minus 1. So here actually is what? Is 16x to the x cube minus 30x. Okay? So we can rewrite it in 13x times 2x squared. 2x squared and minus 1. Yeah? Minus 1. Yeah? So now we can see here. So f prime 0 equal to 0. F prime 0 equal to 0. F prime 0 equal to what? F prime 0 equal to what?
0.
It's also 0, yeah?
Yeah.
So here we do not have a convolution here. So here means that the second derivative, okay, test does not leave it here. So we need to use the first derivative, okay? We need to use the first derivative at this point. So how to do it? So we can see so here I think that here so at this point, okay, at this point, here f prime equal to 0. So here is inconclusive, okay, inconclusive. So now, so here we need to see clear it by the first derivative test, okay. Now the second here, f prime 0 equal to 0, f prime 1 equal to 0, f prime 1 equal to what? F prime 1, okay? F prime 1 actually is 13 times 1 times 2, 1 square minus 1, yeah?
Oh my God.
So of course it's greater than 0, yeah? Here equal to what? Equal to 13 times 1 times 2 times 1 square minus 1, yeah?
13.
It's 13, yeah? So it's greater than 0, yeah? Greater than 0, so here this one is a relative maximum or minimum. So it's a relative maximum or minimum. Greater than 0. Okay, greater than 0 is what? Minimum. And now for the minus 1, f prime minus 1 equal to 0, f prime minus 1 equal to what? F prime minus 1 equal to 13 times minus 1 times 2 times minus 1 square minus 1, okay? So it equal to what? Here 2 minus 1 square is 1. 2 times 1 minus 1 is 1, yeah? So 13 times minus 1 times 1, so it's what? Minus 13, yeah? So of course less than 0, yeah? Less than 0. The first order derivative equal to 0, so f prime less than 0, so it's a relative. So it's a relative what? Maximum, yeah? So these 2 points, we have a conclusion. So how we need to see this point, okay? 0 this point. 0 this point, so here we need to use the second or the first derivative test. The first derivative test, so here is minus 1, here is 0, here is 1. So we need to see the 1, okay? We need to see 1 nearby. 1 nearby. So we just need to see this interval and this interval, okay? This interval and this interval. So here this intervals, and here is f prime. Here is conclusion. Here is conclusion. This interval is minus 1 to 0. Minus 1 to 0. Okay, in this interval, f prime is here. F prime is greater than 0 or less than 0. Here, this one actually is positive. When x in this interval, x square minus 1 is positive or negative?
Positive.
This interval. Positive or negative? When x in this interval, x square minus 1 is positive or negative? Of course, negative. You choose a value in this interval. For example, minus 1/2. Minus 1/2 square minus 1 is what?
Or negative.
It's negative, okay?
It's currently negative.
Positive times a negative, so it's a negative. So here is a minus. Minus, so here means here is what? It's decreasing, yeah? And in this interval, 0 to 1, okay? 0 to 1 in this interval, 0 to 1, this here, this part is positive or negative? Also negative, yeah? This positive times negative, so here is also negative, yeah? So here is what? Here is also decreasing, yeah? So here means what? Here means 0 on the left. On the left of 0 is decreasing. On the right of 0 is also decreasing. So here means what? This point actually is not a relative maximum and not a relative minimum, okay? So in this example, okay, in this example we use the first derivative test and then the second derivative test, okay? Yeah?
Here 30 minus 30.
Mock reality was
30 related minimum minus 30 related
Yeah?
This related minimum and related maximum.
So,
Yeah, 30 is
so here is the second f prime greater than 0 is relative minimum. So you can see the conclusion. The first f prime equal to 0, f prime greater than 0 is relative minimum. And f prime equal to 0, f prime less than 0 is relative maximum.
yes. Can you show examples of the graph? Can you show graph?
So actually, at the beginning, I show you. Y equal to sin x. Yeah. Yeah, this part, okay, at the point 1/2 pi. 1/2 pi, we can see fx equal to sin x. So f prime x equal to what? Equal to cosine x. And f prime x equal to what? Equal to minus sin x. So you can compute it. You can compute it that f prime 1/2 pi equal to cosine 1/2 pi 0. And f prime 1/2 pi is minus sin 1/2 pi is minus 1 less than 0. So f prime equal to 0, f prime less than 0. So here is a relative maximum. This is I give you at the beginning, okay? At the beginning. So here, now, okay, now I think that you need to do an exercise, okay?
সত্যি করে এখন কিন্তু বুঝতে পারবো প্রশ্ন করবো
Here? Now, use both the first and the second derivative test to find the relative extrema of fx. Fx equal to x cubed minus 3x plus 3, okay?
Okay.
So now do this exercise, okay? Do this exercise.
Okay. Actually, you want to do it?
Yeah. Here?
No,
You
no,
try it.
I'm just trying. I'm going to Bangla.
So you do it. Okay?
बहुत टाइम আছে
He likes it.
আমি কি আমি টাইম করে আছে
So I have a break of 20 minutes, okay? I have a break of 20 minutes, we begin at 4, okay?
गांजा खाई सस्ते है भर्ती है करते हैं उड़ा उड़ा बस जी फालतू ब्रेक के मार அந்த மாதிரி கலா কি সব এসব বাংলাদেশের কি সবগুলো আপন ধরে নিয়ে আসে